That's why I'm delayed.
Okay. You need some more time?
No, ma'am. It's opening now. Just.
Okay. You once open it and share it with us. We will check. Okay.
Okay. Can you see the screen, ma'am? Yes.
Wait.
I shared my screen.
Yes, it's visible. It's visible.
Really, I fed up, ma'am, because
Data. It's visible, Saleem.
yes, ma'am.
No problem.
Shall I start, ma'am, or?
No, we'll have a formal introduction, everything. Wait, okay?
Okay.
Okay, and now this session is still 1 o'clock, okay?
Okay.
Then after that, we'll have a lunch break till 2 o'clock. Then we'll start another session at 2 o'clock. No problem, okay? For you.
Okay.
Okay. 1 to 2, we'll have a lunch break. Introduce பண்றது நானே ஆரம்பிச்சிருக்கேன். Okay, Saleem, I think participants are ready. Shall we start? Okay.
Yes, ma'am.
Okay, good morning, everyone. I once again welcome you all for this session 2 of day 5. And here I am happy to introduce the of this session, Dr.A. Saleem Raja. He is now working as a lecturer in Information Technology Department, University of Technology and Applied Science, Shinas, Oman. He is having an experience as a lecturer and researchers with 13 years of experience in both undergraduate and postgraduate levels. And he was working as a guest lecturer even in our department for 2 years during 2006 to 2008. He did his PhD and MTech IT at Bharathidasan University, MPhil at Periyar University, and MC at RVS College of Engineering and Technology, Dindikkal. His research includes machine learning, mobile computing, data mining, and cyber security image processing. He has published over 12 articles in peer-reviewed journals and conferences. And he has a good trainer and giving training on Internet of Things, machine learning, mobile programming, big data, Cisco R&S. He has did several professional certifications on 2020 Cisco IoT Fundamental Connecting Things, 2020 Hawaii Certificate ICT Associate and Academic Instructor, 2020 Cisco Networking Academic Instructor, and 2008 Cisco Certified Network Associate. And one more detail I wish to add regarding his interest in servicing our students, because he was working here for 2 years. He is a well-wisher of a department. So every year, whenever he visits India, he gives some kind of training program to our final year MC and MSIT students to equip them with the latest technology such as mobile app development using Android, IoT programming using Arduino and Raspberry Pi. So this kind of training is actually was supported our students to develop several apps to for the, as the final year projects. So with this, I welcome you, Saleem, once again for sharing your machine learning knowledge with us. Now the session is yours. You can carry on.
Thank you, ma'am. Thanks for your introduction.
Okay.
Actually, it is tough time for everyone to cope up with all our activities. Even though we have some commitments every day, we have to do some other service activity for the basis. We have some guest lecture program. Uh, Whenever I have free time, I used to conduct some guest lecture program to different institutes. I'm happy to share the basic idea of computer vision and machine learning, how we can apply machine learning for computer vision. Okay, so this content I organized in a manner the student who can able to understand, as well as those who are beginner, they can able to understand how to do machine learning in a simple way. Okay, most of us we learn many things about machine learning algorithms, but while implementing those algorithms, we may feel some difficulty because of due to large line of codes in some websites. When you start learning the content, it makes you to bore and you cannot get each and every point of the lines. Okay, so I make it simple so that anybody can easily implement their own ideas. Okay, so with this outset, I'll start my presentation. Okay, so actually I made some changes in my presentation today morning due to some problem with the synchronization with the drive. My data is always in OneDrive, Microsoft OneDrive. So it has a problem with the synchronization. So the content is not properly organized as I planned. So I'll just move here and there. Just you follow the content. Okay. Is it clear? Students, is it clear?
Yes, Saleem, your voice clear and the PPT
Yes.
also clear. You can.
Okay, ma'am. Thank you. And so first we start with, I organize the content like first we have to discuss what is machine learning and what is computer vision and how it is related. Okay, then I will give you some basics of machine learning algorithm. Then we move to the software packages and how to implement machine learning for computer vision. So this is the overall organizing the content. Okay, so I'll start with the computer vision. As we all know, computer vision is part of AI. Okay, so AI is a broad domain where you can find a lot of technologies inside. Okay, the main motive is of AI. It makes the system to understand like a human. Okay, that is the main objective. Okay, for that they have different technologies. So that AI is a broad umbrella. Inside AI, we have different kind of technologies. Okay, like we have machine learning, we have a deep learning, we have computer visions, and many more technologies inside it. But all are related to one point, that is, it used to mimic like a human. Okay, so whatever technologies, whatever components inside the artificial intelligence, it comes into picture where it's like the system. Okay, whatever system we create, that should mimic like a human. Okay, so what is computer vision here? Okay, computer vision is used to derive the meaningful informations from digital images, videos, and visual inputs. Okay, so whatever digital contents we have, we all know digital image processing. Normally what we will do, digital image processing, we can able to enhance the images, or we can explore some components inside the images. Okay, sometimes we reduce the noises, we increase the quality of the picture. So all are comes under image processing. When come to computer vision, we have to understand other images, we have to understand the video. Okay, the system should understand the video. When you see the picture is given in the slide. You can see some people are crossing the road, right? So when you see the picture, you can able to understand as a human, there are some vehicles parked behind the road, I mean behind the persons, and some people are crossing the road. They are well dressed, and all those components we can able to easily, okay, because we can able to segregate the components. Some are cars, some are humans, some road lines are there. All are we can able to segregate because our brain is fully trained to classify all those components, right? Similarly, if you give the picture to the system should understand these are the components, okay, and these are the parts are humans, and these are the parts are other objects, and it has to classify those objects too. Okay, it seems to be simple, but while implementing those concepts into software, then it makes a lot of sense. Okay, you have to go in detail about our human vision, then only you can able to implement the correct way how human brain realize the objects. Okay, is it clear? Is that clear? My voice is clear?
Yes, sir.
Yeah, okay, fine. So the basic task in computer vision is image classification, object detection, object tracking. Okay, so these are the terms you may hear yearly, right? Image classification means you can able to classify, I mean group the images. This is for dogs, this is for cats, this is for fruits, this is for, these are the items are for missionaries, like the system able to classify those items. Okay, and object detections, the content inside the object can be detected, and movements, okay, object movements can also be tracked. Okay, these are the basic operations in computer vision. Okay, so in order to do computer vision, how it works, we have to know. Okay, because our human brain, it is already trained, because when from the childhood onwards, your brain is getting trained every day. Okay, that's why when you see some objects, you can able to classify it, and you can able to understand the characteristics of the object, right? The similar way the computer vision is also working. Okay, suppose if you feed some data, image data into the system should extract the important features of those images, and it has to extract meaningful information and train the model. Okay, train the model. Here I have taken some pictures, mobile, I mean bike and cars. Okay, so I trained those, I gave this input to the system. Okay, the system should extract the important features. Okay, important features of bike, important features of car. Okay, then using these features, okay, using these features, we can able to train the model. We can able to train the model in the sense algorithm. Okay, an algorithm, we train those algorithm. Okay, then the algorithm is best suited for any other prediction. For example, if I give different model of bikes, okay, here I have given some samples. Okay, if I give different samples to the model can able to predict whether it is a bike or car. Okay, this is simple classification how computer vision is working. Okay, so in order to understand, okay, I'm just giving the simple example here. Is it clear now? Yes?
Yes, Saleem. Everyone are in mute state. Okay, you can continue. Okay.
Yes, ma'am. Actually, ma'am, while taking class, sometimes the network issues may come. So we don't know whether our content is available or not. That's why I frequently ask the
Such
question.
kind of confusions going on, then I will surely contact you. I am watching. Okay, no problem. You
Okay,
can.
okay. Thank you. So next we move to machine learning. What is machine learning? Okay, machine learning is a science of getting computer to act without being explicitly programmed. This is the definition given by Stanford University. Okay, all my reference, whatever content I plotted on the PPT, all are getting from the corresponding website. So I gave the reference at the bottom of the slide. Okay, it's not my own content. Okay. The machine learning is the science of getting computers to act without being explicitly programmed. What it means? what it means explicitly program. Usually we do the programs. We are all programmers, because when you join as a computer science student, from the beginning we are trained with a different kind of programs, right? Usually the program is a combination of statements. Okay, it's a combination of statements. Different kind of statements are there. We have conditional statements, we have a looping statements, we have a different data structure to process those data. Usually what we will do when we plan for our output, what output we need based on our input. So we do the coding, we form the rules. Okay, if it is like this, for example, if the male age is this much, you can give this message, or the student is getting this mark, you have to display like this. So we have to write some rules. In the program we write some rules, but machine learning program, we no need to write the rules. But what we have to do here, you can see here the difference. Okay, so the machine learning and normal traditional programming, the main difference. Okay, so usually the traditional traditional programming, we have a data and we frame the rules. Based on the rule, it will give the output. This is normally we do. But machine learning, what we are doing, we have the data, input data, we also have output. We also have output. Okay, when you feed this input and output to the system will, the algorithm, I mean the system means algorithm. Okay, it will create its own rule. Okay, based on the algorithm, it will create its own rule. Okay, so that rule that trained the data. Okay, so based on the input, it will create a relation between input and output. Automatically it will generate some rule. Rules. Okay, this is the main difference between machine learning and traditional programming. Okay, I hope you the picture is clear. Okay, what we are normally doing and what we are normally performing in machine learning. Okay, so how it can be, how it works. Okay, machine learning, how it works. We have a data. The data can be classified into two different parts. One is the training data, another one is the testing data. Okay, so here the new input what we have here, okay, is the testing data. Okay, so we have a training data. So using that training data, we can train our algorithm. Okay, so once the algorithm is getting trained, okay, then we can give the testing data. There's a testing data will give the predictions. Okay, so it will classify, or it will predict what value it comes. Okay, so then we can decide whether this prediction is correct or the prediction is enough. Okay, then we go for further process. Okay, as like IoT system. Okay, if you get some data from sensor, okay, those data you have to form as features. Okay, then you give that data to the machine learning's algorithm. The algorithm will get trained and it will give you the output. It will give you the predictions. Okay, so you have to, as a human, you have to justify that the prediction is okay, or if you need some improvement, then you can do some other additional refinements. Okay, I will tell you what are the refinements we will do at the in the machine learning at the end. Okay, we will quickly move to the content. Okay, so machine learning is, we are not doing explicit program. Okay, it's part of AI. Mainly it inbuilt with the statistical properties. Okay, it includes statistical methods. Okay, in order to create a relation between input and output and generates the rules. Okay, then we move to the main important elements for machine learning is the data. Okay, so how much data that you give to the algorithm, that much it will give the accuracy. Okay, we will see some example. Okay, next is machine learning applications. Okay, just a minute. Machine learning applications here. Okay, so the main important applications here I pointed out. Okay, it may have n number of applications. Okay, so here I'm just pointing few important applications that frequently many research were pointed towards that. Okay, so that's why I pointed few applications here. Okay, social media, user activity based recommendations, this we already know. Okay, so when you search or when you search some content in the internet, it will give some, based on the searching, you will get some notification in your Facebook, you may get notification in your YouTube. Okay, similar like user activity sensing. Okay, based on your navigation pattern. Okay, so those data give some recommendation to the system, so that system will give you promotion ads. Okay, next is product recommendation. As I already said, we can purchase items in the online portals. So based on your frequent searching pattern, it will give some recommendations to that. Okay, then image recognitions. Okay, already I explained what is image recognition. Okay, so it has to understand what is the content of the image. Okay, so whether it's a human means the particular person name, or some kind of analytical work on images. Okay, image recognition. Okay, sentiment analysis, it's mainly for social media. Okay, Twitter and Facebook used to do sentiment analysis. This kind of analysis will help the government and institutions, companies can able to understand the mindset of the people based on our new policies or new technologies. Okay, we can able to get the people opinion through the sentiment analysis. Okay, and healthcare, mainly patient details and patient data that will give the doctors and healthcare professionals some kind of suggestions so that they can do better treatment than the normal one. Okay, so these are the main applications. And now, okay, so there is a point where computer vision and machine learning are tied together, that is training. Okay, so always the system should get trained, then only it can able to act like a human. Okay, so in that point, computer vision is backended by the machine learning. Okay, most of our people, they are trying to implement computer vision with deep learning. Okay, deep learning is fully based on neural network. Okay, so most of the people, they try to implement their ideas through deep learning. Okay, but we can also use a simple machine learning algorithm to understand the images and video. Okay, so first we need to prepare the data. Once our data is ready, we can do any kind of work. Either we can use machine learning or we can go with the deep learning. Okay, so computer vision, backend support by machine learning, that will go beyond the limit. Okay, so next is what are the machine learning algorithms we have? Okay, so we have some algorithms. Okay, so that algorithm, we have many categories: supervised, semi-supervised, unsupervised, and reinforcement learning, and many kind of categories we have. But the main important thing is we have to divide the algorithm into two parts. One is supervised learning, another one is unsupervised learning. Okay, so what is supervised learning here? Okay, supervised learning is where you have an input and output variable, and you have the algorithm to learn the mapping function from input to output. Okay, so for example here, we have a data, input data is, you can see the small table on the slide. Okay, we have a data, square feet, number of bedrooms and number of bathrooms in the flat. Okay, so 3000 square feet, 3125 square feet, 5 bedrooms and 3 bathrooms, the price is this much. Okay, 530. Okay, the price is $530. Okay, I'm not reading fully, I'm just pointing some price details. Okay, so we have a price also. For every data, we have a input is there and the output, the price is also there. Okay, but if you give new data, okay, the last line you can see there are 3,950 square feet. There are 6 bedrooms and 4 bathrooms. Okay, what will be the price? Okay, we may need. Okay, that can be predicted with the help of this trained data. Okay, so input is there and output price is also there. So what it will do, the function f, it will create a rules. It will create a rule between your input data and the price. Then you can easily able to predict what will be the price of new data. Okay. Similarly, if you trained with some apples, okay, the algorithm is trained with some apples. When new data comes, okay, new data comes based on the apple features, it can able to detect whether it is apple or some other fruits. Okay, so we have an input and we have an output. Okay, so that is guided usually. Okay, so when input is there, output is there. Okay, it is guided. That's why it is called supervised learning. Okay. Next one is unsupervised learning. Okay, so what is unsupervised learning here? Unsupervised learning is only having the input data and no corresponding output variables. Okay, for example, if I ask you to group some students, okay, there are a bunch of students on the ground. Okay, if I ask you to group the students, normally what we will do, we just go and we don't know the details of the students, we don't know the particulars information about the students. So what we will normally do, we just separate boys separately, girls separately. From the boys, we can arrange them in a height wise or age wise, like that. Okay, the same way the algorithm will also work. Okay, when you give the data, it does not know what kind of object is this. Okay, but based on the features of the input, it can able to bring out some groups. Okay, it can able to group the items. It can able to group the items. You can see here, we give the input as some fruits, and we extract some features from the images, and we feed the data to the algorithm. The algorithms get trained able to group the items. So future some testing, if you give some item, it can able to segregate the items. Okay, for example, if you test with some apple, it can able to group the size based on the size and color. It can able to group the item. The system is not know the particular name of the fruits, you have to give it, but anyway it can able to segregate the items. Okay, so this is unsupervised learning. Okay, some small mistakes on the PPT. Okay, please ignore it, because the PPT which I modified today morning, it was not open, so that's why I use the last copy. Okay, so please bear with that. Okay, I will send after the presentation, I will send the full PPT to you. You can just go through it. Okay, next is supervised and unsupervised learning. We have a classifications. Okay, supervised learning, we have a classification algorithm, we have a regression algorithm. In the regression algorithm, we have a linear regression, we have a logistic regression, and classification, we have different models. Okay, like SVM, and many classification models are there. Okay, so what is classification? Okay, classification is a problem when the output variable is a category. Okay, so there is a main difference. So regression and classification. Regression, we have a continuous data, like as I already show you, right? Some rooms and room features, flat features, like number of rooms, number of toilets and square feet. All these things is a component. Okay, the price is a continuous value. Okay, so that is the example of regression. Okay, classification is a model where you have a male or female, human or animal. You can able to classify, right? That is a categorical. Okay, so basically classification is used for to categorize the content, categorize the input. Okay, that is classification. Regression, we focus on values, real values. Okay, like weight, price. Okay, dollars. Okay, so we focused on real values. And clustering, as it comes under unsupervised learning, where you can able to group the items, you can able to group the data. Okay, association ruling, association analysis, that helps to identify the hidden patterns. Okay, from the customer buying patterns, from the human behavior patterns, some patterns you can able to explore. Okay, with the help of association analysis. Okay, these are the major algorithms. Next, we will move to the specific algorithm. Supervised learning, we have a linear regression, we have a logistic regression, naive Bayes classifier, KNN neighbor, K nearest neighbor algorithm, decision tree, and random forest. Inside decision tree, we have another class, random forest. Okay, and support vector machines. There are many algorithms there. Okay, so every algorithm, there are some properties. Okay, when you start learning, you have to understand why it is supervised, why it is unsupervised, and inside the supervised learning, okay, how the algorithms are differ. Okay, so then only you can able to apply the algorithm in a proper way. Otherwise, the data is good, the algorithm that you are selecting is maybe not suitable for your data. Okay, so then the output will also affect it. Okay, so you have to understand the algorithm. I'm not go in detail about every algorithm because it takes a lot of time. Okay, so I will show you how to implement that algorithm. Even you don't have the idea, you can learn by different algorithm, by training. Okay, by different attempt, you may do some different attempt practice, then you can easily learn all those algorithms because everything is packed. Okay, no need to go in detail about the algorithm, how it gets work, and how you feed your data. All those things is everything is packed. So just you have to plug and play. Okay, wherever you need, just you plug and play. Okay, so please go through all the models, okay, all the algorithms, okay, so that you will choose the right algorithm on the right place. Okay, next is how we can extract the features. Okay, as I already said, okay, for computer visions, we have to understand the content of the image. Okay, computer vision, we have to understand the content of the image. So in order to understand the content of the image, we have to get the data from the image. Okay, we have to get the data from the image. So we have to apply some image processing methods to get the features from the image. Okay, so usually how we store the images in the machine, okay, we have pixels. Okay, when you see the image here, okay, the photo is a group of bunches of pixels. Okay, so that's why I placed two photos. One is actual number, okay, another one is the pixels view. Okay, how it is represented in the system. Okay, if you have a colored image, okay, color image, okay, so then the image, we have pixels, the pixel groups, we have a red green blue because RGB colors. So we have a separate pixels for every color channels. Okay, so this is the basic of image representation. When you get extracting the features, okay, so there are many ways you can able to explore the features of image, because if you are good in image processing, then you can explore different features of the image. Okay, so once you extract the features, then you can apply machine learning algorithm and you can predict, or you can do classification, okay, or you can explore the hidden patterns of the image. Everything you can able to do. Okay, so we have a two tasks. One is we have to process the image first and extract the features. This is the first work. Once you extract the feature, then you go for the machine learning to explore. You have to predict, or you can classify, or you can explore the hidden patterns. Any kind of work that you need, you can do. Okay, for example, infection of corona. Okay, if you take infection of corona lungs images, okay, the lungs image, when you analyze as a doctor, okay, sometimes you may predict wrong. Okay, so in order to do with the mission, okay, you can able to accurately classify whether it is infected or not. Okay, so how it can be, you have to explore the features from the image. Okay, so this is the basic. Then how to extract the features. Okay, I'm going to give you some basic steps, because I'm not in deep in image processing, but anyway, if whatever data comes, as a data scientist, we have to explore the data. So I start learning all kind of data. Okay, how to extract the features from images, videos, audio. Okay, so different data we have to explore. Okay, so in such way, I'm going to give you a basic step how to explore the features from the image. Okay, so here are some of the methods. Okay, the first method is the grayscale picture values. The first method is a grayscale picture values. Okay, so first you have to change the image, whatever image that you have, into gray level pictures. you can ask the question, why should we change to gray level? Because in order to reduce the color channels, okay, in order to reduce the color channels, okay, we have to change the image to grayscales. Grayscale, we have a two option, black or white. Okay, the combinations will be there. So we have to change our pixel to grayscale model. Then after changing it, we have a pictures. Okay, as you see here, we have a pictures. All the image pixels, we have to extract, and we have to create a vector. We have to create a vector. Okay, so don't think that it is a much complex task. Okay, simply you can load the data and make it as an array. Okay, make it as an array. Okay, so normally what it will do when you extract the image data and put it into the array, so it may be two-dimensional array. Okay, usually we have a two-dimensional array. Okay, but two-dimensional array data, it cannot be suitable for the machine learning. Okay, it cannot be directly, you cannot feed the data, two-dimensional array data to the machines. So what you have to do, you have to change into one-dimensional array. Okay, you have to change into one-dimensional array. Okay, so then the data, you can store it as a file, then you can able to feed into the system. Okay, so that is the best, that is the main thing. Okay, next one is next method. Okay, next method is extracting the edges. Okay, we have different image processing, we have different edge detectors. Okay, we have Sobal and we have Canny, and many edge detectors are available. The packages are pre-built packages are available. So you have to change, you have to apply that edge detection algorithm on the image, and you will get the extract edges. In the extracted edges, you can able to extract the pixel values and you can feed into the system. Okay, this is another method. Okay, third one, we have to take the mean pixels value. Okay, mean pixels value, we have a red, green, blue, three different channels are there. Okay, so in the channels, we have to take the pixel value and we will create a new array with mean value of all those pixels. Okay, you can see here different pixel values. It is cumulated, and we have to take the average and we'll create a new picture array. Okay, so that will keep the mean value. Okay, is it clear now? So all the three ways we have. Okay, one is the grayscale pixel value features, and we have edge features. Okay, then we have a mean pixel value of the channel. Okay, you can ask, sir, this is very simple and handy way, but is there any other features we can able to extract? Yes, we can do. We can use histogram based extractions. Okay, once you change your image into histogram, then from histogram you have to explore the features. And sometimes if you want to identify the faces, human faces, then you have to grab the image, the face. Okay, there are many masks available, right? You can able to detect the face of the human, and each human face you can able to explore different attributes like length of the nose, eyebrow size, all those features you can able to extract. Then you can able to give training to the algorithm. Okay, so there are different ways. Here I'm just pointing out very simple basic ways so that you can extend your idea. Okay, so this is the basic. Don't think that this is only the way. Okay, there are many ways to explore it. Okay, but how you explore it, that is the question. Okay, because you have to justify your selection. Okay, why you are choosing this, and whether your data is accurate, everything you have to think, and you have to process it. Okay, next is this is the way. Okay, I will show you some simple example. Okay, you can able to understand how things are there. Okay, I think that the image is missing because I modified some content that was missing. Okay, okay. I will show you in the particular website, it gives the detail. You. You can see here the flower. Okay, the flower we call as iris flower. So in the flower, you can able to classify this flower by extracting the features. Okay, so how it can be, we can able to measure the height and width of the petals. Okay, we have to measure the height and width of the petals. Then we can feed this data to the algorithm. You can able to explore, you can able to predict, or you can able to classify, okay, new data. Okay, this is one simple data, because actually all those data sets are available. You can download from the internet. Okay, this is one good website towards data science. You can get more informations and how to implement all those concepts. So many articles frequently coming. If you have time, just go through this towards data science. Okay. Next is what are the software packages we need? Okay, so that is very important. Okay, what are the software packages we need in order to implement image processing and machine learning? Okay, combined together, and we can create a computer vision system. Okay, so we have a following packages. We need a following packages in order to implement the algorithm in Python. Okay, so first I will explore in details about Python. Then we will see how we can extend our idea to Java. Okay, we can implement in both ways. Okay, so first I will explain in Python. Okay, then we will go to Java. Okay, first package that we need is scikit-image. Okay, so this package, we can able to perform all kind of digital image processing actions, as well as feature extraction, face detection, and many operations we can use with the scikit-image, because all the basic operations are available. The scikit-image, one of the main features, it will easily convert the image into pixel arrays. Okay, so that is a main feature. So we can easily directly you can use that pixels array. Okay, because it is yes, ma'am.
Put it in a presentation mode.
Okay. Okay. Is it okay, ma'am?
Okay. You can continue. Okay.
So all the image processing operations you can perform with the scikit-image. Okay, scikit-image inbuilt with NumPy array, so you can easily export your image into array. Okay. So next is we have a OpenCV for Python. Okay, I think almost everyone we know about OpenCV. Okay, in order to process images, we need OpenCV. Okay. So this is another package you can use. Okay, it's up to you. What are the packages that you want? Okay, some filters, some algorithms you may have in OpenCV. Some algorithms you may have in scikit-image. Okay, based on your comfortability, you can choose either scikit-image or OpenCV. Okay. OpenCV you can implement in any platform, and it will also support with different languages. Like you can implement it in C++, you can implement in Python, and you can implement in Java, and many language supports available for OpenCV. Okay, we have a SciPy scientific module, which also help to process the image. Okay, because it is also convert our image into array, so we can apply different filters on it. Okay, SciPy, some filters, specific filters like Canny or some edge reduction filters is available in SciPy. Okay, and the basic model is NumPy. Okay, so we all know arrays. Okay, from C++, Java, and many languages, they have the feature basic data structure, that is array. Okay, but Python, it takes the array into the concept of array into next level. Okay, you cannot imagine this kind of things in any other language. except Python, because it explore in array in different way. Okay, you cannot imagine in that way. Okay, so when you experience with NumPy, then you will realize why we struggle a lot with other programming languages. Okay, so NumPy is one of the core Python library and provides support for array. Okay, so we had to convert our image into array, so we had to use NumPy. Okay, so next is Pillow is another package. Okay, it's also available to process the images. If you want, you can use Pillow, you can use Scikit-Image, or you can use SciPy, or you can use OpenCV, whatever packages that you want, or you can combine all those packages. Only some of the important functions that you need, you can also combine. Okay. Next is how to install those packages. Okay, already you know Anaconda. Anaconda is the IDE where you can have bundles of Python interfaces. Okay, so it combined different IDE into one platform, which is much easy to use. Okay, you know how to install the Anaconda. Okay, you have to visit this website. You can download the particular Anaconda version, whether you are using Apple Mac OS or Windows OS or Linux OS. Based on your system, you have to install the Anaconda. Okay, once you install the Anaconda, there are prompt available. I will show you. Okay, command prompt for Anaconda. Anaconda prompt is available. Same like our command prompt. Okay, so you can use these commands. Okay, for example, if you want to install NumPy, you have to use see here, it's coming now. You can able to type all the commands which I highlighted here in order to install the Anaconda. Okay, install the particular package in Anaconda. Okay, first you have to install Anaconda. Okay, so once you install Anaconda, there are different interfaces. You can install your packages, whatever packages that you need, you can easily install. Okay, so for installing NumPy, we have some commands. To install the Panda, we have a command. If you want to install OpenCV, we have a command. And we have a SciPy, we have a Matplot package, we have a Scikit-Image package, and we have a Scikit-learn package. So all the packages you have to install first. Okay, when you copy and paste the particular command in the terminal, it will start automatically. If you have internet connections, it will automatically extract the particular package from the internet source and install in your machine. It is it is not much difficult task. Okay. And also you have installed in a graphically. Okay, I will show you later. Okay, so this is the basic step. You need a Anaconda software, and once you have Anaconda software, you can easily install other packages, whatever you want. Okay, next is the basic programming elements. Okay, basic programming elements. Here, just a minute, I will check my PPT if it gets open. Okay, so it comes the way which I organize. These are the softwares which we require. Next is feature extractions. We already discussed. Okay. Next is important thing is I want to show you this one. Yes. Okay. When you have an image iris data set, okay, iris data set, you have to explore the image data into array of single dimension array. For example, here different iris flower. Okay, one is versicolor and setosa and Virginia. Okay, so this image they are extracting the sepal and petal length and width. Okay, small leaf and big leaf. Okay, that is petal and sepal. Okay, their size they measured and they classify. They put it in a data format, that is a basic elements. And last column you can see class. Okay, so we also give the output. This is for Setosa and this is for versicolor. Okay, so we can give data as well as the class label. Okay, this is the input and output. Okay, once you feed into the system, it will automatically frame the rules. Okay, this is the thing. And we move to the important implementation part. Okay, the first one is I'm going to show you how to import the images. Okay, so here you can see some of the code, very simple code. You can able to extract the pixel values from the image. Okay, so first thing, you have to load data into Python. Okay, so how to read image data? Can you see the code clearly?
Yes,
Can you see?
yes.
Yes. Okay. We have a package, scikit image package. Okay, so in the scikit image package, we can able to read the data. So import the package, scikit image package, and read the data with imread. Same like a MATLAB we use imread function. Same way we can also use here to read the image, a single image. If you want to read a single image, you have to use imread to read the image and store it in a variables. Okay, so that you can use further. Okay, right. Next one is the imread underscore collection. You can see here imread underscore collection. What is the use of this? Okay, we can able to read bunches of images. Okay, suppose you want to extract the features from thousands of images. Okay, then you have to use imread collection. Okay, imread collection, it will extract the pictures one by one, and it will load the picture into the variable. Okay, so then you can able to process one by one. Okay, so this is one way. Okay, next is converting image into pixel. As I said, the first model, we have to convert image into grayscale. Okay, so how to make image into grayscale? Simply we have imread and image with the path where you stored your image, and as gray is equal to true, then the image will be changed to gray levels. Okay, and you can also use some other packages to change the image as gray level. You can also use a color package inside scikit image. Okay, you can see here at the bottom RGB to gray. Okay, you can also able to change your image into grayscale. Okay, this is how you can read the image, and you can able to convert the image into grayscale. Okay, next is you can usually the images, when you download from the internet, or if you keep a scanned copy of the image, okay, usually the image size is bigger. You have to reduce the image size, then only you can able to process it, because otherwise, for example, if you take 50 into 50 size, okay, height is 50, width is 50, then the image pixels, number of pixels is 2500 pixels. Okay, imagine if you have big size images, then number of pixels is more. So you have to reduce the size. In order to reduce the size, we have a resize method. Okay, in scikit image transform package. Okay, so you can resize the image. I hope everyone know the Pythons, right? Otherwise, the code, if I show the important points, then you may think that this is something different one that you have, right? So already you know the Python, right? Students, madam?
Yes, most of them are working with Python.
Yes, then no problem. Okay. So we have to read packages, resize. We have to use resize package. We can able to reduce the size of the image. Okay, sometimes when you reduce the size of the image, we have some zigzags. You can able to reduce that also. Okay, and we have a we can able to save the image also. You can see here on the bottom we have a im save. Once you process the image, you can able to save that image in your location where you want. Okay. Next is display the image. How to display the image after processing? We have a im show. Okay, im show, you can able to display the image on the screen. Okay, and as I already pointed, IM save. You can able to save the image in particular location with your particular name. Okay, so that also possible. Okay, so all these are the fundamental coding for image processing in using scikit image package. Okay. Next, we move to scikit-learn. Okay, why we go for scikit-learn? Because we are going to implement machine learning algorithm in scikit-learn using scikit-learn. Okay, any queries now? Any queries now?
No, Saleem, you can continue. We'll see.
Okay, okay, okay.
Yeah.
Scikit-learn package. It has bundles of algorithms. It has bundles of algorithm. We can use any algorithm. We can use any algorithm. First, we have to understand how the algorithm gets work. Then we can choose a particular algorithm based on our requirement. Okay. So main task for choosing the algorithm. Main criteria for choosing the algorithm is the data. Okay, so you have to pre-process your data. So most of the time, 50 to 60% of your effort is to pre-process your data, because the data, usually when you get it, okay, it may have some missing value, it may have some noises. Okay, so you have to clean those data, applying some different methods. Okay, so in Python there are two important packages. One is NumPy, another one is the pandas. Okay, so we have to use pandas. It has bundles of methods to pre-process your data. I hope you know pandas. Okay, panda is a data frame. Okay, you can make your data to you can able to view as a table. Okay, so you can create your data, okay, array of data into a data frame, okay, by using panda. Okay, if you don't know pandas, please go through panda and numpy. If you're comfortable with numpy and panda, you can easily implement any of your idea, okay, for machine learning. Okay, okay, I'll go to scikit-learn package. So if you want to understand how to implement machine learning algorithm, okay, don't see the headings because I did not change the heading. Okay, so just follow the content. Okay, because I just do it in the last moment, so I did not change all the titles. Okay, once I finish, I will correct and send to you as a mail. Okay. Next is when you implement scikit image. Okay, so we have a series of steps we have to follow. Okay, already I said we have to load the data first. Okay, after loading the data, we have to separate our features. Okay, you can see here. You can see here we have some data, right? So we have some data here. Okay, in the data. Some are actual features. Okay, the last column that you have as a target class. Okay, so you have to segregate your features and the target class. Okay, so first thing you have to load your data. Okay, first thing you have to load your data. Okay, so the data, usually we keep the data in a Excel file. Same like Excel file, we keep our data in a CSV format. Okay, CSV format, or if you go with open or if you go with Veka, okay, so we have a R format. Okay, so all are same like a Excel sheet. Okay, so you keep your data in an Excel sheet. Okay, CSV file. CSV mean comma separated values. Okay, comma separated values. So that CSV file as an input for image classification. Okay, so I'm taking image classification problem. Okay, so first we have to load the data. Okay, second part, you have to separate what are the features and which one is the target class. Okay, so both should be, you have to split. Here you can see, here I'm giving the Excel. Okay, so what are the columns? What are the columns for data? Okay, that means features, and which one is the target. Okay, so we have to segregate these two. Okay, next is we have to split. Training set and test set. Okay, So next one is you have to split your data. Okay, so whatever data that you have, that will be splitted into two parts. One is the training part, another one is the testing part. Okay, for example, I have 1,000 records in my data. Okay, so I can able to give 70% for training and remaining 30% of data for testing. Okay, so we can able to divide training and testing. Is there any fixed rate for dividing training and testing? No. Okay, you can give different options. For example, I can divide the training 50-50. I can divide 60-40. I can divide 70-30. I can divide 80-20. It's based on our need. Okay, so you can even you can measure how your algorithm, how your system is performed by different value of training and testing divisions. Okay. Here we have a method, a train test split. Okay, you can see the method on top. Okay, train test split. It is comes in sklearn model selection package. Okay, so that function we can able to divide our data. So our data is here, data, and what is the target, and we have a test size, and test size we can give training size and test size, or when you give test size, automatically training size it will take. Okay, so here I'll give 30% test size. Okay, and remaining 70% is training size. That is the meaning. Or you can explicitly specify training and testing. Okay, how much you want training, how much you want testing. Okay, both you can specify. So it will return four different values. Two value for data and two value for target. Okay, so we have a two group of data. One is the feature data, another one is the target data. Okay, so in the feature data, 70% for training and 30% for testing. Similarly, target data, we have 70% for training and 30% for testing. So four values it will return. One is the data trained, and second one is the data test. Similarly, target train and target test. Okay, so you have to understand, please. Okay, we first divide the features and target separately. Okay, so we have to give the data for training. Okay, so in that case, you have to divide the data. So we have two data sets. So you have to divide 70-30 models. Okay. Next is you have to choose the algorithm. You have to choose the algorithm how to implement your model. Okay. So here we sklearn, we have many algorithms. Okay, many algorithms. We have SVM, we have random forest, we have logistic regression, linear regressions, and decision tree. Okay, so many algorithms are available. You have to choose even naive-Bayes algorithm. Okay, so you have to choose your model. Okay, that's why I choose Gaussian naive-Bayes. Okay, so different naive-Bayes, we have different algorithms also. Okay, so Gaussian naive-Bayes, here I choose, and I'll store it in a model. Okay, so this is a normal variable. You can give any kind of variable name. Here I am giving as a model. Okay, so once you have a model, then you can fit your data. Okay, so in order to do the training to the algorithm, you have to give data train and target train. Please note it. This is important. Okay, so when you give the training, you have to select the training data only. Okay, so I will write it here so that you can better understand. So our data, okay, so we divide the data into two. Okay, one is training data, another one is testing data. Okay, so training data, usually we have a data in two parts. One is the feature set, another one is the target. Okay, so how to divide this? So features, we have a training, and also we have a testing. Okay, similarly, target, we have a train data and test data. So when you take training, okay, if you want to give training to the algorithm, you have to take the trained data. Okay, what are the data is related to for training? Those data you have to select it. When you go for testing, you have to select the test data. Okay, so that's why we have here trained data. Okay, data trained, that is feature trained, and the one is the target trained. Once you have trained the model, you can able to predict. Okay, so how it will be? You have to give the test data. You have to give the test data, but you are not giving the target. You are not giving the target. You are giving only the feature data. So it will predict. The value. It will predict the value. Okay. So next is we can use here. I am using naive Bayes algorithm. We can also use k nearest neighbor classifier. We can use SVC. We can use a random forest classifier. It comes in different packages inside sklearn package. Okay. So it is very easy when you search in the Google for SVC, automatically the package and all the methods you can easily learn. Okay, I'm not going in detail, but you can easily learn. Okay, so different packages are there for implementing different models. Okay, here k nearest neighbor classifier. How many neighbors you want? Okay, based on the neighbor, it will group the data. Okay, so here neighbor arguments are given, and SVC we have a gamma support vector. We have a gamma value. Okay, so based on the gamma value, the algorithm performance will vary. Okay, and we also have random forest. How many trees levels that you want, you can give estimator value. Based on that, it will create a random forest. I mean, the D tree will be created and classifications will be performed. Okay, so this is the basic thing for sklearn. Okay, so how to measure the accuracy? Okay, after predictions, we have to make the accuracy. We have to measure the accuracy. So that is a accuracy score function. So we have to give. You can see here the last line. Okay, so the predict function, it will give the prediction. Okay, so the prediction value is here. So you have to check this prediction value with the actual value, right? So then only you can able to compare the accuracy, right? So here we have a prediction. Okay, you can see prediction, and also we give a target test. You can able to test how much accurate the classification is. Okay, and here normalize is true. That means it will round off. Okay, normally it is a fractional value. You can able to round off, or if you want a fractional value, you can do it by using normalize argument. Okay, so this is all about machine learning. Okay, so machine learning, we have different steps. I'll just repeat it. First, we have to load our data using pandas data frame. Once you have a data, you have to split the data into feature and target. Once you split it, then you can decide how much data you need for training and testing division. Once you have a training and testing division is ready, then we can go for model preparation and testing. Okay, so here one important feature is their random state. Okay, so what it means, random state, it will give a consistent output for all your running. For example, if you run your algorithm in number of times, your output may vary. Okay, so when you do the classification, sometimes it gives 90% classification accuracy, sometimes it gives 89%, sometimes it gives 88%. So different accuracy it may give, because every time when it takes testing and training, okay, with different data samples, so accuracy may vary. Okay, so in order to keep the accuracy on same level, you can give random state any integer value, so automatically the output will be consistent. Okay, or if you give random state as none, okay, random state is run, what will happen? It will shuffle the data for every run. Okay, when you do running, okay, before it will go for testing, before it will go for training, okay, all your data is shuffled. Okay, then every time when you run, you will get a different outputs, different classification accuracy. Okay, you may ask the question, Mister, if you give a different level of accuracy in every run, then how you can measure the particular accuracy of the algorithm or system. Okay, so we have to run in multiple times, and we have to take the average. Okay, this is one way. Another way is we have a different validation methods. We have different validation methods, tenfold validation and many validations available. So you have to apply the validations. So automatically it will validate your data. Final accuracy value will be given to you. Okay, so this is one thing. Okay. Next is how to measure the accuracy. Okay, here we have some formula. So accuracy measurement. So true positive and true negative. Okay, on top, and the bottom we have a true positive, false positive, true negative, and false negative. Okay, so based on this value, we will get accuracy results. Okay, what it means when you have a testing and training samples. Okay, so the prediction is 100% correct. That is true positive. Okay, prediction is 100% negative. Wrong. That is true negative. Okay, so here somewhere between positive and negative, that is false positive and false negative. Okay, actually it is positive, but it shows negative. Okay, actually it is negative, it shows positive. Okay, so that combinations we have. Okay, so based on that we can able to measure the accuracy. Okay, so next is this is iris data, and all the references here I pasted, so you can go through if you have time. Okay, so this is all about the basics. Next is I will move to how to work with Python. Okay, any queries, please?
Participants, do you have any queries? Saleem, I have a question.
Yes, yes.
You splitted the features into feature data and target data, no? Actually,
Yes,
the
yes.
features are given in a tabular form. Okay.
Yes,
So from
yes.
the image, we are extracting the features. That is, we are calculating, making some calculation like height, width, likewise, we are producing this table. Okay.
Yes, yes, yes.
In this table, feature set means all the columns are considered to be the feature data. Yes.
Yes, yes, ma'am.
Yes, but only the final label is considered as a target data. Am I correct?
Yes, 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 ma'am. For example, if you take a human face, for example, Virat Kohli, I have a Dhoni, I have a Sachin, I have different faces. Okay, so all the features I extracted and placed in a tabular form, and the final column can notify that these features are Sachin, these features are Dhoni, these features are
I think they
Gandhigram.
are labels. Huh?
Yes, yes,
Yes. Okay. They are known to be the targets.
yes, yes.
Okay. Okay. And one more thing here, you mentioned about the accuracy, na, and formula given for the formula. Okay.
Yes, yes.
What about the role of ROC?
Region of interest, you're asking, ma'am?
No, ROC, receiver operating characteristics. Curve, they will draw some curves between sensitivity and specificity, and they're calculating accuracy and that.
Actually, ma'am, I just plot one accuracy formula only. There are different measures.
Measures are there. Yes.
Yes, yes. Different measures are there. Based on your problem, you can define your own formula also.
Okay, okay. Depend on the application, we can define. Okay.
Yes, 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 ma'am.
And one question is posted by
accuracy calculation, common formula. That's why I just plotted. In addition to that, different measurements. We have a F score. We have a precision. Many measures are there.
This is anyway general concept used with all applications.
Yes, yes, yes.
One question is posted by one participant. What is the difference between PyCharm and Anaconda?
PyCharm, it inbuilt with all the packages are in the Python, but some features, if you want to work with PyCharm, you have to get the license, and most of the features they give free. You can work with IDE, no problem. But most easy way to work with Python is Anaconda. Okay, so if you work with PyCharm, no problem. Okay, whatever program we discuss today, all the programs will work with PyCharm also.
Okay.
Different. Specialized in.
Mr. Nagendran asked it. So can we use Anaconda in PyCharm? He asked once again. So your answer is we can use. Okay.
No. Actually, Anaconda is a different IDE and the PyCharm is different IDE. Okay, so which one you want, you can use. No problem.
No problem. Okay.
Coding will be same. The coding will not differ.
Okay. So participants, any more
for example, if you work with Java, some different IDEs are available. Somebody using BlueJay, somebody are using NetBeans, somebody are using Eclipse. So different IDEs are there. It's based on their convenience.
Okay. So any more questions?
Shall I go to programming small parts, ma'am? Then remaining program I will explain in the afternoon session.
So now, how long it will take, Saleem? Almost we are reaching 12:50. It seems.
Just 5-10 minutes, ma'am. I'll wind up.
You finish this within this session. Okay, you carry on.
Yes. Okay. So basics. I hope the basics are clear. Okay, there is a relation between computer vision and machine learning. So the basics are clear. So I open Jupyter. When you open Anaconda, I will show you. When you open Anaconda Studio. Okay. So sorry, Anaconda. Anaconda Navigator. Okay, there are different components are there. Anaconda Navigator. Okay, different IDEs are there. You can use any of your choice. Okay, so it's an integrated platform. It's an integrated platform. You can use any of your choice. Okay, so I prefer to use Jupyter. Okay, so once you open Jupyter, I will show you once Anaconda is get ready. Okay, I will show you Anaconda screen. Will take a few seconds to open. Meanwhile, I will show you Jupyter Notebook. Okay, so Jupyter Notebook, once you install Anaconda, automatically it comes. You can see here Anaconda Jupyter. Okay, so when you have, okay, the Jupyter Notebook is available. So once you click Jupyter Notebook, it will open browser. Okay, browser is the interface you can work with Jupyter. Okay. So in the Jupyter Notebook, it will explore all our folders in our system. Okay, all our folders in our system. So where you want to keep your files, you can choose it. Okay, here if you want to create a new folder, you can create. Okay, so if you want to create a new folder, you can create. Okay, once you have a folder, then you can create a new files, Python files you can able to create. Suppose you want to write a complete program, okay, full code. If you want to write, you can create a text file, write all your code and save it as a Python. Okay, this is the basic step. Okay, so once you have a Jupyter, once Jupyter is open, you can able to see all the IDEs available. Which one you want, you can use. Here I choose Jupyter. So Jupyter is a browser-based IDE. You can easily work anywhere. Okay, very simple IDE. You can see here, this is the Anaconda Navigator. Okay, so you can have Jupyter Lab, and we have a Spider. Spider is one of the IDE, and Qt console. Okay, and many IDEs are inbuilt with Anaconda. Okay, so which one you want, you can choose. Here I use Jupyter Notebook. Okay, for my convenience, I choose Jupyter Notebook. Other IDEs are also available. You can use it. Okay, so it frequently updates. We can also use RStudio in Anaconda. Okay, PyCharm professionals, you can use it here. Okay, if you have license, you can use it here. Okay, so all the IDs are available. Which one you want, you can use it. Okay, so here I use Jupyter. Okay, so Jupyter, it will explore once it is opened. Okay, it will explore all our system folders. Then wherever you want to create a folder, you can create, and after creating the folder, you can create your files. Okay, for example, if I want to create a new Python file inside one folder, okay, for example, I have my files. Okay, so I have a files here, image processing folder. Inside image processing folder, if I want to create a new file, I can create a new file. Okay, so you can able to create a folder, and you can able to create a file. Okay, and also we have a terminal. Okay, what is the purpose of the terminal? Terminal is the same like a command prompt. It will display. You can type command to run the program. For example, text file. If you have a bunch of code, if you want to run as a program, you can use terminal to run the program. Okay, that is also available. Okay, so I will open the first one because we don't have time. So I will quickly move to the code. Okay. Okay, so first I will open one plain notebook. Okay, so the plain notebook here, for example, if I create a variable, okay, so for example, a equal 10 and print a, okay, so when you run, it will show the output here. Okay, so whatever code that you want, you can type and click run. Okay, automatically you can get the output on the screen itself. Okay, so that's why many of the people like to use a Jupyter Notebook for their application development. Okay, here I have a code. Okay, I already show you the code for loading the image and using scikit image package. Okay, here I use Dhoni image. Okay, to load the image. Okay, so I have the folder. I have the folder image set. Inside the image set, I have different images. Okay, if you want to see, I will show you. This is a Dhoni image. So I have some images. Okay, so in the image, I read as a color image, and I read a image, and I'll change as a grayscale. Okay, so first I will show you color image. Okay, so hash symbol used to make the line comment line. Okay, so make the line deactive so we can see the output of the first line. Okay, I am sure it's used to display the images on the screen. You can see here on top Python 3 black icon. Okay, that means the program is running, so we have to wait for the output. Okay, running. Initially, it will take a few minutes to set up. Okay, then after it will give much quicker output. Okay. Output image. Okay, so I will run again. You can see here. So it loads the image. It loads the image and it also shows the height and width of the image. Okay. Next is if I want to change the image into grayscale, so we can able to change it. So grayscale. I hope the lines are very simple. You can easily understand. Okay. So I am read. You can able to read the image and store it in a variable. Okay. So that variable will be used for further process. Okay. So when I run grayscale, change to grayscale image. Okay, so next is if you want to find the size of the image. Okay, if you want to if you want to find the channels, okay, color channels of the image. Okay, so first one we have a color image and second one is the gray image. There are two variables we have, color image and gray image. When you run color image, okay, it shows the size of the image is 745 into 615. Okay, channel is 3. Okay, because 3 colors are there. But when you have a gray image, okay, it has a one channel. Okay, it has a one channel, so it shows only the height and width of the image. Okay, so next is dimension of the image. Okay, so color image, it has a 3 dimension. Okay, we have a color image dot ndim. Okay, color image dot ndim. So that code will display dimension of the image. So we have a 3 channels, and here we have a grayscale image. We have a 2 dimension. Okay, and next is how to resize the image. Okay, already we have image sizes 740 and 615. Okay, so we have to reduce to 300 into 300. It depends on you. If you want to reduce very small, you can also reduce. Okay. So we have a image size and anti-aliasing is false. That means zigzags will not be there in the image. Okay, you can able to see the image in the bottom. Okay, and this is the basic operation of images. Okay, next one, how to read a collection of images. Here I gave the folder to read all the images from the folder. Okay, so all the images are in one time star.jpg. Okay, so all the images it will take, we have to use imread collection. So that will show, that will display the I mean, it will read all the data from the folder. Okay, because we cannot, every time we cannot load all, one by one. So it will read all the images from the folder. Okay, so once it is read, it will display in a single row. So that's why I use matplot to plot the images. Okay, matplot is a package, so mainly for drawing the images on the screen in a row and column wise. Okay, so I use matplot subplot function to draw the image on the single row. Okay, so I have 3 different images. Okay, so all the images are loaded here. Okay, so any doubt in this?
No, Saleem, you can continue.
Okay, that's it, ma'am. To the afternoon session, I will show you how to extract the images, image features. Okay, then how to create a file. Okay, how to train the algorithm. Okay, then I will also show you how to work with Java. Okay.
Okay, okay, fine, that's fine. Okay, Saleem. I think I will take a break for lunch now. Okay.
Okay.
Then afternoon we'll join at 2 o'clock. Okay, thank you so much, Saleem. And
Thank you.
participants, you can go for your lunch now, and you will come and join at 1:50 for our next session. It will start at 2 o'clock. Thank you, Saleem. You too take a break and finish your lunch and come. Okay. We'll meet
Okay.
at
Okay.